Hi, and welcome to Mr. Garofolo's podcast. In this episode, we are looking at simplifying square root radicals. In today's class, we got cut a little bit short towards the end of class and didn't do as many examples as I had hoped. I'm going to pick up with some examples from the classwork section of the packet. I'm going to start with example D, which is the square root of 128. So before we get started with how to simplify this square root, just want to remind you how to use your calculator for square roots. On your calculator, to access the square root function, you would need to type in second and then the x squared key, then enter the value of the radicand, in this case 128, and hit enter. So here's the value of the square root of 128. As we discussed in class, this is an irrational number. Although the calculator shows the decimal ending here at the digit 5, that's only because the calculator can't show you any more digits. This would be a non-ending, non-repeating decimal, since the radicand is a non-perfect square. Let's keep this value in mind, or this approximation, or this rounded value, in mind as we work to simplify on our worksheet. So back to our worksheet. We want to now simplify the square root of 128. To do this, we're going to use the multiplication property we learned today. And that is, we can express 128 as two factors and write those factors each under their own radical symbol. The key is that one of these factors should be a perfect square, and more importantly, it should be the largest perfect square that is a factor of 128. So one thing we might see at first glance is that 4 times 32 are a pair of factors of 128. And 4 is a perfect square. So this seems like it would be logically a good choice for simplifying this expression. However, as you look down your perfect squares list, there's a larger number that's a perfect square that's also a factor of 128. And that would be 64. 64 times 2 would also give us a product of 128. 64 happens to be the largest perfect square that's a factor of 128. So this is the one we'll want to choose. Once we have used our multiplication property in this fashion, then we can extract the square root of 64, which is 8, and bring down the non-perfect square, 2. So we have 8 times the square root of 2 as what we think is equivalent to the square root of 128. Now we can go back to our calculator and we can verify the values. So this time we would type in 8 times the square root of 2 and see that we get the same approximated value. So these are the steps for simplifying a square root radical. Let's try one that has a coefficient in the problem. So in problem F, the value 8 is called a numerical coefficient. In this case, it is the value that precedes the radical expression. You may have seen these last year in variable expressions. For instance, in expressions like 2x or 4ab. The coefficient would be the numerical value preceding the variables. Now, the same thing is true in a radical expression or square root radical expression. The number preceding the radical is your coefficient. We're going to bring that coefficient down to the next line. We'll be multiplying it by whatever whole number we get from our perfect square. But first, we've got to simplify the square root of 98. So once again, we're looking for a perfect square that's a factor of 98, specifically the largest perfect square. As you work through, you may want to pause the video right now to try and find the largest perfect square that divides into 98. Go ahead and do that, and then when you're ready, press play again. So did you find it? That's right, it's 49 and 2. The square root of 49 would be 7, so we're left with 8 times 7 times the square root of 2. And now we're going to multiply these coefficients. And we end up with 56 times the square root of 2, or 56 radical 2. Now again, you may want to go into your calculator, type this in, get an approximated decimal value, then type in this expression, get an approximated decimal value, and make sure they're the same. So there are some examples for you on simplifying radical expressions. Let's take a look at how we could apply it to the Pythagorean theorem. If we look at letter I, it says to solve for the value of x in the right triangle below. Write the answer in simplest radical form into the nearest tenth. So towards the end of last year, you learned about a very famous theorem for right triangles called the Pythagorean theorem. And that's what you'll need to use here. You probably remember it as this: a squared plus b squared equals c squared. Let's review what those letters represent. The a and the b represent the legs of a right triangle. The legs are the two sides that meet to form the right angle. They also happen to be the shortest sides. The c is the hypotenuse, and that's the side that's always across or opposite from the right angle. So in this problem, we're asked to find a missing length of a hypotenuse, x. But we know the values of the legs. So we could replace a and b with 2 and 6, and replace c with x, or you could just leave it with c. And then we're going to solve for x. So we would have 2 squared is 4, 6 squared is 36. The sum of 36 and 4 is 40. Do you remember how to solve from this point forward? Pause the video and give it a try. Well, if you did the square root on both sides, you got it right. To solve x squared equals 40, we'll need the square root of 40, the square root of x squared. The square root of x squared is x. The square root of 40, well, that's an irrational number. So the nearest tenth can be found by using your calculator. And it would be about 6.3. In simplest radical form would require us to simplify the square root of 40 using perfect squares. The largest perfect square that's a factor of 40 is 4. The other factor would be 10. The square root of 4 is 2. Leave the non-perfect square. So our answer could be approximately 6.3. A more exact answer would be 2 radical 10, or 2 times the square root of 10. Well, I hope this podcast was helpful. If you use these examples and principles to guide you through the homework, you should find some success. Your homework is the following pages, the back page, excuse me, going from number 1 all the way up to number 17. If you have any questions, feel free to email me at school, and I'll be sure to get back to you as soon as I can. Thanks, and see you in class.